The earliest members of our very own genus, Homo, were rather strange creatures. Homo habilis, for example, retained the features and habits of the Australopithecine apes they descended from, while possessing unique human intelligence qualities that set them apart from other animals. While habilis is the most famous of the early Homo species, it was not the only early human alive at the dawn of our genus. In Sub Saharan Africa, on the grassy plains, and in the open woodlands of the Rift Valley, Homo Rudolfensis also made its home. Homo Rudolfensis is one of the more mysterious species on our family tree, in part due to the fact that very few remains have been identified belonging to it. It existed at a time when several species of early humans were living together in the same places, and it is hard to isolate and assign remains specifically to this species. That's not to say we don't know anything about Homo Rudolfensis, however, and today we will be taking a look at how this species lived and survived on the plains of ancient Africa. How was Homo Rudolfensis set apart from its contemporaries? What did it eat and where did it live? How was it identified and what can we learn from its remains? These are all questions we aim to answer in today's video. Sit back and relax as we take you back to the Pleistocene to meet Homo Rudolfensis, one of the earliest species of human in the fossil record. Homo Rudolfensis lived in what is now East Africa, between roughly 2.5 to 1.5 million years ago. Specifically, its remains seem to be centered around Kenya's Lake Turkana, one of the largest salt lakes in the world, situated in the country's northern reaches. Today, the region is surrounded by desert, but in Homo Rudolfensis's day, Lake Turkana would have been surrounded by greenery. This is also how the species gets its name. Lake Turkana was referred to as Lake Rudolph when the first Homo Rudolfensis remains were discovered in 1972. Those first finds were described by Kenyan paleoanthropologist Richard Leakey, who would later find fame as a prominent wildlife conservationist of endangered African species. In rocks surrounding Lake Turkana, fossil hunters would uncover an almost complete skull, belonging to an as of the time undescribed species of hominid. Larger than those of the contemporary Homo habilis, the skull was also situated near to several femur bones, although their relationship to the skull was unclear. Later finds would be made by Kamoya Kimeu and Bernard Nyaneo, a Kenyan paleontologist and local fossil collector respectively. It was Richard Leakey that first constructed the Homo Rudolfensis skull from the initial discoveries at Lake Turkana. He first showed the species as having a large brain case and a flat face, but the skull has undergone several transformations since then. Anthropologist Timothy Bromage would later revise the reconstruction of the face, altering it to show a face with a 5-degree incline, rather than one that was completely flat. Studies surrounding Homo Rudolfensis's evolutionary history are ongoing, but scientists have put forward several theories as to how it came to be on the plains of Africa. David Cameron, the Australian anthropologist, and not the British politician that is, in 2003 put forward the idea that Kenyanthropus platyops was the ancestor of Homo Rudolfensis. He suggested this based on Mark Collard's previous theory that Rudolfensis should have been a species of Australopithecus and not Homo. Kenyanthropus remains have been found along the shores of Lake Turkana slightly before Homo Rudolfensis arrived on the scene. Cameron put forward the idea that Rudolfensis was more closely related to Paranthropus, another species of hominin contemporary to Rudolfensis, rather than Homo habilis. Other researchers have argued that Homo Rudolfensis, along with several other Homo species, should be considered synonymous with Homo erectus, but no certain evolutionary ties can prove this from evidence in the fossil record. There are even more discrepancies when it comes down to individual bones and which specimens should be considered to be Homo Rudolfensis and which belong to other species. As well as the bones found around Lake Turkana, Bones from Ethiopia and Malawi may also be attributable to Homo rudolfensis, but not enough evidence is present for researchers to make a definite statement on this. Early to Middle Pleistocene hominin study can often be a strange minefield of confusing specimens and difficult identification. Today, Homo rudolfensis is widely considered to be a distinct species, separate to Homo erectus and Homo habilis, with Rudolfensis being more closely related to the latter. While the exact origin of the Homo genus has not been determined, Rudolfensis may be a contender. LD 3501, a jawbone that represents the very oldest specimen attributable to Homo, may belong to Rudolfensis. It may also belong to habilis and could be an ancestor to both species entirely. It dates back to around 2.7 to 2.8 million years ago and was found in Ethiopia, very close in both time and space to the rise of Homo rudolfensis. Whether or not Homo rudolfensis represents one of our earliest ancestors or a separate branch near the base of our genus's family tree remains to be seen. In life, the face of Homo rudolfensis would have resembled a human's with prominent ape-like features. The face was indeed very flat in comparison to our own, and the face was very broad, making the species' facial features look smaller in comparison. Its mouth was wide and protruding. It had a prominent brow ridge above its eyes, and its nose was flat, closely resembling those of gorillas and chimpanzees. A notable feature of the jaws of Homo rudolfensis is that the molar teeth were covered in particularly thick enamel, some of the thickest seen in any of our ancient relatives. This may have been an adaptation to help it chew tougher food than some of its contemporaries. If an adult Homo rudolfensis was to stand next to a fully grown modern human man, there would be a significant size difference. Based on estimates made from the proportions of the skull, an adult male rudolfensis would be considered tall if they grew to 5.5 feet, with most reaching a little over 5 feet. Females were slightly shorter, measuring just under 5 feet. Males are thought to have weighed about 60 kilograms, or 130 pounds, while females weighed around 51 kilograms, or 112 pounds. Like other early hominins, such as Homo habilis, Homo rudolfensis was thought to have been covered in a layer of thick body hair, retained from its Australopithecine ape ancestors. This may also point to Homo rudolfensis inhabiting slightly cooler regions than, say, the later Homo erectus, which was thought to be hairless. It can be difficult to discern information for certain about human species whose remains are incomplete in the fossil record, but thankfully scientists can tell a great deal from hominin skulls. The teeth in Homo rudolfensis's skull, thick with enamel, indicate that this species was eating tougher foods than its relatives, who lacked this feature. Tougher plant species, or tougher parts of plants, would have been consumed with little challenge by this early human, without running the risk of their teeth being worn down over time. They may also have been able to withstand tougher meat than the Australopithecines or Homo habilis, which would have allowed them to access a wider range of prey items when hunting. What's more, is that Homo rudolfensis' lower jaws were thicker than its relatives, which would have allowed it to resist the wear and tear of these food items while it was eating, avoiding strain or damage to muscles and bones. As a result, Homo rudolfensis's bite force may have been unusually strong for an early human. While Homo rudolfensis was able to tackle this wide range of foods, it did not appear to have any grasp on tool use or creation. Homo ergaster, a later species, is known to have produced basic stone choppers and blades, but in the very early Homo species, this ability seems to be absent. It does not appear to have affected Homo rudolfensis' ability to acquire food, however, and this species likely ate as much meat as its tool-bearing relatives. To obtain food without tools, Homo rudolfensis would have acted as part of a troop, mobbing prey, or taking carrion to obtain meat. they would have spent a great deal of their day-to-day lives foraging for plants and fruits to supplement their meat-heavy diet, and may have traveled long distances to do so. It is unlikely that such hunter-gathering was organized to any degree, and that these animals rather intermittently sought out food when the need arose, sporadically heading into the forests, grasslands, and hills to obtain a meal. The shorter stature of Homo Rudolfensis, as well as its Homo habilis contemporaries, indicates that it probably lacked the endurance running capabilities seen in later species, such as Homo erectus. It could not rely on speed and stamina to chase down prey to exhaustion, and may have taken smaller animals, or the remains of carcasses that had been brought down by more capable hunters. As the climate in Africa dried out, it is thought that this species, along with our other earliest Homo ancestors, relied more upon roots and tubers to obtain food, and spent time digging through the earth to find them. Homo Rudolfensis was without a doubt a highly social animal, as are all great apes. As their brains grew, they would have developed social skills and complex hierarchical structures within their family groups, similar to those seen in modern-day chimpanzees. They may have spent long periods of time grooming one another to strengthen their social bonds, and, like chimps, may have been led by a dominant male, who would gain the right to mate with and defend several females. These apes likely gathered, traveled, hunted, and rested together, finding safety in numbers out on the open grasslands and sparse woodlands of ancient Africa. It is, however, thought that early Homo species rarely strayed too far from the trees they once called home. As they were incapable of endurance running, Homo Rudolfensis likely sought safety in the branches of trees when danger approached. Evidence for this comes in the form of the species' longer arms in proportion to modern humans, which would have helped it climb through the branches to evade big cats or dangerous reptiles. Homo Rudolfensis coexisted with several other species of hominins, most notably Homo habilis, to which it was very closely related. Like Rudolfensis, habilis would have been covered in hair and retained many ape-like features, both in the face and body. Like Rudolfensis, their arms were long and were used for hoisting themselves up into the trees to protect themselves. Homo habilis are believed to have been a direct ancestor on the eventual line to Homo sapiens, and may have been capable of some basic tool use. Homo ergaster also lived alongside Homo Rudolfensis, and was one of the last of the early Homo species. There are many similarities between ergaster and the later Homo erectus, the latter of which may be considered some of the first visibly human early human species. While ergaster was ancestral to the later hominins of the Pleistocene, it was capable of tool use and was an efficient hunter of large game out on the plains surrounding Lake Turkana. Finally, and perhaps the strangest of the hominins to accompany Homo Rudolfensis in ancient Kenya, was Paranthropus boisei, distinctly not a species of Homo, P. Boisei was much more gorilla-like and would have been covered in a layer of fur. Like a gorilla, its skull featured a prominent sagittal crest, and while it would have walked upright, it would have much more closely resembled its ape ancestors than species in the genus Homo. Paranthropus boisei may even have used very simple bone tools to dig up tubers and access insects from inside their nests. The abundant lake shores of Turkana were not a safe haven for early humans, despite the large quantities of food and hominin remains. This was a dangerous world in which our early ancestors were not the top predators. Every day would have been a struggle to survive in a constantly changing and wild landscape, filled with predators and dangerous herbivores alike. Interestingly, one of the largest threats to Homo Rudolfensis may have been the members of its very genus, Homo habilis. Both of these early humans fed on similar foods, inhabited the same regions, and relied upon the same resources. To ensure there was enough food and space to satisfy their troop, these species may have come into frequent competition with one another. It is impossible to say what these confrontations may have looked like. Perhaps they were purely intimidation displays with vocalizations and arm movements. There is, however, the possibility that competition in such a dangerous world could have taken a violent turn, with savage attacks and even fatalities occurring for those who did not back down. Knowing how dangerous chimpanzees and even humans themselves can be, this may very well have been a deadly possibility. Without a doubt, the most dangerous predators of Homo Rudolfensis and the ancient humans it coexisted with were not each other, but the big cats that roamed the African wilderness. Cats have been a constant threat to humans throughout our evolutionary history, and one of the most prominent and deadly was Dinophilis, a genus that was widespread across Africa, Asia, Europe, and North America from roughly 5 to 1 million years ago. Many human species would have encountered, ran from, and sadly lost their lives at the fangs of this big cat, which was distantly related to the mighty Smilodon of South America. Throughout prehistory, fossil remains of hominins have been interspersed with those of big cats, and it would appear that Meganterion, another ancient saber-tooth, was also responsible for a great deal of early human deaths. Roughly the size of a jaguar, this would have been a camouflaged ambush predator, more than capable of hunting our ancestors through the long grasses of the ancient savannas. Whilst biting down on the head or neck of its victim, Meganterion would have pinned down its prey with its large, powerful paws, rendering it unable to escape. Moreover, there is some debate around whether or not Meganterion may even have been able to pursue our fleeing ancestors up the trees they sought protection in, rendering few places truly safe in the ancient world. As well as these extinct species, Homo Rudolfensis also would have had to contend with leopards, likely the most prolific predator of early humans, and lions, which were relatively new arrivals on the grasslands of Africa when Rudolfensis evolved. These species survived into the modern day and can, on rare occasions, still pose threats to unprepared or unaware humans in the areas they live. Other dangers were represented by carnivorous reptiles. Around the shores of Lake Turkana, crocodiles lurked, ready to ambush our early ancestors. Homo Rudolfensis would have been a prime target for these predators as they came down to the water's edge to drink. Since these humans appeared to congregate around the lake often, we can assume that they relied heavily upon it for water and possibly food, and as such, crocodiles may have been a constant threat. In the long grass amidst the savanna of ancient Africa, Homo Rudolfensis also needed to be constantly aware of venomous snakes. One misstep could have rendered an early human on the receiving end of sharp fangs and deadly toxins. There is also evidence that danger may have come from the skies for early humans. Australopithecine children, the predecessors to Homo Rudolfensis, may have been hunted by African crowned eagles. Puncture marks have been found in their skulls, made by the aerial carnivore's long, piercing talons. If a young Homo Rudolfensis found itself straying too far from the troop, there's every chance that one of these airborne apex predators could have struck from above, carrying the poor victim off to its nest. If predators weren't enough to deal with, Homo Rudolfensis also lived in a world full of large, aggressive herbivores. While these animals did not actively hunt our ancestors, they would have been extremely dangerous to share the grasslands with, and many a Rudolfensis likely lost its life to an attack from one of these giants. Today, hippopotamuses are one of the most dangerous animals in the world. Capable of extreme bursts of speed, both on land and in the water, and armed with long tusks used for jousting with rivals, they can easily trample an unlucky human. If Homo Rudolfensis found itself too close to a group of hippopotamuses, they may easily have met their end. A whole host of other modern animals also lived on the African plains with Homo Rudolfensis. namely rhinoceroses and elephants, both of which are capable of posing immense threats to humans, especially ancient, unarmed species such as Homo Rudolfensis. In the breeding season, these animals become especially dangerous as they are charged with hormones. Homo Rudolfensis would have certainly needed to steer clear while it was out foraging. Homo Rudolfensis represents one of the most fascinating yet confusing of our ancient ancestors. Like many early to middle Pleistocene humans, it suffers the same fate of being sparse in fossil content and difficult to identify. Studies are ongoing, which will hopefully prove one way or another how Homo Rudolfensis fits into the wider family tree of our genus. And with any luck, we may soon be able to reveal the very earliest origins of our kind. Could that origin sit with this very species?